Okay, let's unpack this. Imagine a world where, the tiny parts powering everything, your phone, advanced AI, they're just getting smaller, faster, more efficient all the time.
It's incredible, really.
Right, we're talking semiconductors. And today we're doing a deep dive into this intense global race to build the next generation, specifically these 2 nanometer gate-all-around or GAA transistors.
Hmm.
And we're really zeroing in on a pretty significant new player in this high-stakes game, Rapidus. That's the Japanese semiconductor company. They just hit a major milestone prototyping these 2 nanometer GAA chips.
Yeah, and what's really fascinating here isn't just the technical achievement itself, though that's big.
Right.
It's how it sort of reshapes the whole competitive landscape.
How so?
Well, we need to compare them directly against the established giants,
Yeah.
TSMC and Samsung. And this deep dive, it's really crucial for you, our listener, because understanding these dynamics helps us grasp where all technology is heading.
Right, from AI down to everyday gadgets.
Exactly. And even the sort of strategic power balance globally, it all ties back to these tiny chips.
So for this, we've pulled together key points, a detailed comparison note, all based on the latest info we have that's as of July 19th, 2025, just to give you the clearest picture possible.
Good stuff.
All right, let's jump into this incredibly complex world of microchips. Let's see who's really leading the charge right now.
Let's do it.
Okay, so let's kick things off with the big news. The thing that really put Rapidus on everyone's radar.
Yeah.
This 2 nanometer GAA transistor prototyping announcement. What exactly did they pull off?
Right. So on July 18th, 2025, just recently, Rapidus announced they started prototyping these 2 nanometer GAA transistors. This is happening at their IM1 wafer fab up in Hokkaido.
Okay.
And crucially, they said they've already achieved the expected electrical performance. For Japan, this is, well, it's a massive step,
Oh.
a serious comeback attempt in advanced chip making.
But how does that stack up timing-wise?
See, that's the key context. If we connect this to the bigger picture, Rapidus is aiming for mass production in 2027.
2027, okay. But TSMC and Samsung, they're way ahead on the timeline, both targeting mass production for their 2 nanometer chips in 2025.
Wow, so 2 years earlier.
Exactly. So it clearly positions Rapidus as, yes, a new player, moving incredibly fast, which is impressive, but definitely starting from behind in this specific advanced node race.
We've said 2 nanometer GAA transistor a few times now. Can you break that down a bit? Just how tiny is 2 nanometers and what's this gate-all-around thing all about?
Sure, so think of a transistor like a tiny, tiny switch controlling electricity. A nanometer, that's a billionth of a meter. So 2 nanometers it's almost impossibly small.
Hard to even visualize.
Right, and gate-all-around, or GAA, that's the structure. Instead of the control part, the gate just sitting on top of the channel the current flows through. It literally wraps around the channel on all sides. This 3D structure gives engineers much better control over that current.
Ah, okay. So better control means.
Less leakage current, higher performance, and better power efficiency. All packed into that incredibly tiny space. Big architectural shift. That sounds like an amazing feat of engineering, just designing it. But the real challenge isn't just the design, is it? It's actually making millions, billions of these things reliably.
Precisely. Manufacturing at scale is the huge hurdle.
So how ready are they? Rapidus, you mentioned, moved incredibly fast, setting up their IIM-1 fab in Hokkaido.
They really did. The pace was exceptional. Groundbreaking in September 2023, clean room ready by December 2024, over 200 advanced tools installed by June 2025.
That sounds lightning fast.
It is, but, and this is the crucial point you raise, they are still in the prototyping phase.
So if they're still prototyping, how big a deal is that compared to companies like TSMC and Samsung who've been running huge fabs for years? Is that gap surmountable?
Well, it's a monumental hurdle, and here's why. TSMC and Samsung, they had these massive established fabs, decades of optimization, running at enormous scale.
Right.
TSMC, for example, they've reportedly already hit over 60% production yields for their 2 nanometer process.
60% yield on 2 nanometer already.
Already.
Yeah.
And Samsung is apparently targeting 70% yields within 6 months of starting production. That kind of experience, that efficiency advantage, it's huge. Yield is king in this business.
Okay, that really puts Rapidus' challenge into perspective, but I heard they're doing something unique with their manufacturing process, something about single wafers.
Yes, that's fascinating. Rapidus is pioneering what they call fully single-wafer front-end processing. It's a global first in terms of commercializing it, part of their RUMS, Rapid Unified Manufacturing Service.
So what does that mean practically? Single wafer versus batch?
Exactly. Traditional manufacturing processes batches of wafers together through each step. Rapidus, however, is optimizing each individual wafer in real time.
Okay.
This allows for these tiny micro adjustments, wafer by wafer. Potentially, this could improve yield, cut down on waste, maybe integrate AI-driven tweaks more effectively.
Interesting. More flexibility, perhaps?
Potentially, yes. And they were also the first in Japan to get that crucial EUV lithography equipment up and running.
Ah, yes, EUV. For listeners, remind us why EUV is so essential here.
Sure. EUV stands for Extreme Ultraviolet Lithography. It's the technology that uses light with an incredibly short wavelength to etch the microscopic patterns onto the silicon wafers.
Necessary for these tiny feature sizes.
Absolutely essential for 2 nanometers and beyond. Rapid has got their EUV tools operational by April 2025. Now, TSMC and Samsung, they also rely heavily on EUV and very advanced controls,
Right.
but they mostly stick to that traditional batch processing. So Rapidus' single wafer approach paired with EUV could offer advantages down the line, maybe in flexibility, maybe cost.
But it's not proven yet, at least not at mass production scale.
Exactly. The benefits still need to be demonstrated at the kind of scale the market demands.
Okay, so they're taking some bold, innovative steps on the manufacturing tech side, but ultimately what customers care about is performance. What can we actually say about Rapidus's 2-nanometer cheek performance based on this prototype?
Well, the prototype shows promising basic electrical characteristics, things like conductivity, voltage. The fundamentals seem okay. But here's the kicker. Specific comparative metrics, things like speed, power efficiency, how densely they can pack the transistors, those details are not publicly available for Rapidus' 2-nanometer.
And what does that lack of detail usually suggest in this industry, especially when you look at the leaders? What numbers are TSMC and Samsung talking about?
Yeah, usually that silence suggests the numbers aren't quite competitive yet, or at least not ready for a direct comparison. In stark contrast, TSMC's 2-nanometer process is reported to offer like a 10–15% speed boost,
Okay.
0.25–30% lower power consumption, and about 15% higher transistor density compared to their previous 3-nanometer node.
Significant gains.
Definitely. And Samsung's second-gen 2-nanometer, they're talking up to 12% better performance. Their third-gen aims for maybe 20–30% improvement. So given Rapidus hasn't released comparable benchmarks,
It seems pretty likely they're not quite at that same performance level yet.
it seems highly probable, yes.
All right, so we've covered the tech race, the manufacturing hurdles, the performance picture, or lack thereof. Let's talk strategy and market power. TSMC, Samsung, how do they dominate?
Well, they're truly global behemoths, right?
Yep.
They command absolutely massive capital investment, which you absolutely need in this game.
Billions and billions.
Oh, yeah. And critically, they've already secured huge orders from the biggest names in tech. Think Apple, NVIDIA, Qualcomm, AMD for their 2-inlay chips. They basically control the supply chain for the world's most advanced computing.
That's immense market power. So where does that leave Rapidus? Are they trying to muscle in and compete directly for those same huge orders? Or is their strategy different?
That's a really crucial point. Rapidus isn't just trying to replicate the TSMC Samsung high-volume model, it seems. They have very strong backing from the Japanese government.
Right, significant investment there.
Yes, and strategic partnerships. They're working with IBM on the 2-nanometer tech itself and with Leti in Europe for future 1-nanometer research.
So a collaborative approach.
And their market strategy appears focused more on specialized AI chips and custom orders rather than trying to supply chips for every smartphone on the planet.
Ah, so a niche play maybe? High-value custom work?
Exactly. It's like a calculated bet that the future demands not just the absolute fastest chip for everyone, but perhaps the most adaptable or precisely tailored chip for specific high-value applications. This could definitely carve out a strong niche for them.
But they don't have the scale or the broad customer list of the big two right now.
Correct. They lack that massive scale and the established broad customer reach of the leaders. For now.
Okay, so laying all this out, the picture seems pretty clear. Rapidus has made incredibly fast progress, which is impressive in itself.
Truly remarkable speed, yes.
But the evidence really does suggest they are currently behind TSMC and Samsung on the development timeline, on fab readiness for mass production, and on publicly proven performance numbers.
That seems a fair assessment based on what we know today.
But their strategy is different, aiming for that specialized market. So wrapping this up then, what we've unpacked today really shows this fascinating, incredibly high-stakes race in semiconductor tech. Rapidus, clearly, they're an agile, innovative new force, building fast, pioneering new techniques like that single wafer processing.
Definitely an impressive entrant. However, as of today, July 19th, 2025, they are, still playing catch-up to the sheer scale of the established customer base, the proven metrics of TSMC and Samsung.
Right.
But the deeper insight, I think, is that their strategic focus, specialized AI, custom orders, backed by government support, that's not just a plan B. It seems like a smart, differentiated approach.
So not competing head-on, but finding their own path.
Exactly. It could position them very competitively in the long run.
Yeah.
Even if they aren't chasing those highest volume, general purpose chip orders, they're playing a slightly different game. And honestly, that's what makes watching them so compelling.
So what does all this mean for you, listening right now? Think about it. This high-stakes race, this quest for the impossibly tiny. It's really not just about getting slightly faster phones or better graphics cards.
It's much bigger than that.
This is about national economic strength, it's about the future capabilities of artificial intelligence, and fundamentally, it's about who controls the most basic building blocks of our entire digital world. This deep dive, it really makes you realize the future is being built, literally, nanometer by nanometer, and it's this intense global competition with these huge, often unseen implications for absolutely all of us.
Well said.
Thank you for joining us on this deep dive. Until next time, keep digging, keep learning.